Hello, I'm going to see if I can cover this very important topic here in 15 minutes. I'll try my best. So this is really important because I think most people do not understand the difference between, hey, why aren't you working? Go back. Is it shift? Control? Which one? This one. I don't think many people understand the difference between a theory and a law and a hypothesis. And I've even heard teachers within our school misuse these, science teachers nonetheless. So the main goal is to differentiate the difference between a theory, a law, and a hypothesis. And it's very important. It's the first step for understanding science as a whole, and evolution falls under that same umbrella. So it makes me laugh that the same arguments I have, or I hear people say against evolution, can be applied to anything. Chemistry, biology, the atomic theory, cell theory, gravitational theory, it's all the same. The thing is that evolution just bugs people, and they try to make frivolous and false accusations. So let's just move on. So one of the reasons I became a science teacher is because of this right here. What is the point of science? The point of science is to gain knowledge. That's actually what science means, is knowledge. And I love trivia. I love Scholars Bowl. I love appearing smart, and sometimes that even works, and I look smart. But that's because I want to know things. I want to understand how stuff works. When someone tells me something that's interesting, I usually didn't know it beforehand. I'm like, oh, that's so cool. I never thought about that. It's so great. Or, oh, do you know where the phrase 3 sheets of the wind comes from? Do you know where the phrase rule of thumb? Or do you know why something happens that way? And in some sense, that applies not to just biology, but everything. I've always been fascinated by why or how, and I love gaining knowledge and understanding of a vast array of things. But how do you, when you hear something new to you, how do you know it's true, or it's real, or it's not fake, or it's actual, or does it make sense? And that's exactly what we do in science. Is, as a young kid, I was always so curious. I always made observations. I would notice things, and you probably know people like that just notice things or look at the world in a way that you don't. And they'll ask questions like, hey, have you ever thought about what do blind people see in their dreams? What happens to us when we die? They just ask these insane questions. You're like, I've never thought about that. And it all starts with these observations and questions. And I always encourage my classes to take guesses, because sometimes you'd be surprised at how, once you know how to think, especially scientifically, you'd be blown away at how many times your guess is correct. And now that I've been a teacher for so long, honestly, students ask me things, and I give the answer. Really, I actually give them an answer, and then when they leave, I think about it and go, oh my God, was that right? I mean, it makes perfect sense, and I just took another concept I knew and applied it to that. Oh, did I just lie to that kid? I go and Google it, and I'm right. And I don't know if it's either because I knew that already, or my guesses are so good and I'm so confident in my guesses that they are right. So that's very important, to make a hypothesis and a prediction. And we test these. And we test them with experiments designed to prove ourselves wrong, to disprove us. And, we've seen the trend over and over in science. How many times people have made really almost imaginative guesses that turned out to be right. So the whole point of science is it means knowledge in Latin. It's a search for knowledge and truth. We try to explain things in the not in the supernatural. We explain things in the natural world. So in a lot of ways, that leaves room for religion and a God. If you tried to explain the Jesus Christ the Jesus Christ resurrection story from a scientific standpoint, it's impossible. You can't do it because it's supernatural. It's within the realm of God's power. So obviously, science is not going to work there. But science also doesn't claim to try to. We only explain things in the natural world. The other 10% of the world, well, that's got to be answered by a different process. We don't prove. It's kind of impossible. We can just only rule out things. And what you're left with are the possible, perhaps probable explanations for a phenomenon. So let's talk with a hypothesis. It's an educated guess. It contains if-then. It has to be testable. It really can be a stab in the dark. It can be speculation, It can be made by a single person. And you design experiments that as time goes by, if you have a hard time refuting it or disproving it, every time that happens, it actually gains support. But it only takes one time for it to be disproven for the leg to be kicked out from under it. And that doesn't happen as often as you think. Some of the really wild claims that Albert Einstein made, 80% of them were shown to be correct. And of the 20%, it took us probably 70 or 80 years to really go, oh, you know what, he wasn't right. But a lot of what he said still was. So it's like, yeah, we got to rewrite this because technically there's some changes we need to make there. This is really the word that most people should use in place of the word theory. When people say, oh, I have a theory about that, it's like, I think technically you have a hypothesis. You have a guess. So here's some examples. I can't find a place to put. Hey, come back here. Go back up, please. Yeah, what in the French toast? For example, I heard this one time. I don't know if it's 100% true or not, but if you've ever noticed how yawning is contagious, so sometimes just hear the word yawn can make you kind of sleepy, and then one person died. Sorry. I'm sure some of you, you can feel it. Resistance is futile. You know you want to yawn now. So there's a phenomenon. Now, we can't argue whether or not that is happening. There's a phenomenon that yawning seems to be contagious. It's also contagious within species. Your dog may yawn. It may make you want to yawn, and vice versa. But we think that with primitives, especially primates, we see it, especially in social animals, intelligent animals. And we think that it at one time may have been a signal as it gets darker that diurnal animals like us that are not nocturnal, we seek safety at night in caves or in trees or in some sort of shelter. And oftentimes when one kind of does that, it serves as a signal, like asking, since they go, hey guys, it's getting dark, do you think we should go to bed? They can't do that. So lots of times you'll see one baboon or a primate of some sort, an ape, a gorilla, chimpanzee, a bonobo, they'll all do it, and they all go and kind of go to sleep or find somewhere safe. So it's like, maybe that's kind of like a suggestion, like, should we go to bed? Deja vu, that's another thing, right? This is the one that's not a hypothesis. I have an idea of what deja vu is. You need to tell us what the explanation is. If the TV is not working, then it must not be plugged in. If the sun goes around the earth, then maybe you understand the universe. All of these are just examples of like, hey, if this should be the case. Here's what I think. I'm going to test it, and this should happen. If primates yawn to signal that it's time to go to bed, maybe that's why it's contagious. Like, hey, now that's very, very hard to prove or support or disprove. It's very difficult to do that. Something like that may never actually be completely accepted or proven. It's very difficult. And yet that's the same concept for every single theory in science. It's like, oh, well, at what point do you go, oh, that's the answer? You kind of never do. I wish we had time to go into what deja vu is. If we do at the end of this lecture, I'll tell you, it's very interesting. So how's that different from a law? Well, laws are, let's say you've looked at lots and lots of experiments. It's the generalized statements made from all these experiments, observations, and studies. In some sense, if we go back to this example with the yawning being contagious, this is your hypothesis. If it was a signal to go to bed, then that's why it's contagious. Your law from that would almost be like, yawning is contagious. It's like, that's the underlying bedrock. That's the statement that can be made from that. These are facts. Gravity, for example. It's this smaller object is attracted to this larger object, and the force of attraction is dependent on how much bigger the big object is compared to the small one, and it's also dependent on how close the two objects are together. For example, the tides of our oceans are controlled by the moon, which is pretty small but very close. It's also controlled by the sun, which is very large but very, very far away. So that's like, well, there seems to be this small thing attracted to a larger thing. We jump up, we're the small thing, gravity pulls us back down to Earth. So that's the law of it. Laws are lots of times made like this. This is the law of gravity. It's a small object and attracted to a big object as a function of the size of the two objects and their distance. This is the law of gravity. We can measure it. The smaller object is attracted on our planet at a speed of an acceleration of 9.8 meters per second. That is undeniable. What's a little different is, let's see here. We talk about this. We have tons of information with the law of gravity. We've observed it on different planets, on different moons, on our planet. It's all over the place. This is really key right here. Laws describe a phenomenon. They do not explain it. You can describe until you're blue in the face. This is everything you'd ever need to know about the law of gravity. Here are the various explanations or theories as to what's going on. We don't really have a good explanation. As much as we know about gravity, we really don't fully know what's making it happen. Isn't that strange that we kind of look at it, observe it, measure it? We can't see it, obviously, but we can see its effects on objects, but we don't know why. Think about that. That is really kind of unsettling in a lot of ways. The best explanation to me is that if the universe is a closed system, if you will, imagine taking a ring and stretching a piece of elastic like rubber or a balloon across it. Well, when you put another object in there, you have to stretch the rubber to make room for that object, and the rubber will push against it. If you put a very big object, the universe pushes against it. If you put a very small object, it creates a very small void that the universe pushes a little less. And it's kind of like, well, you put a big planet like Jupiter, the universe forces back in all directions. And it's like, whoa, that's some deep stuff. So maybe we'll never know exactly what causes gravity or explain gravity, but we can describe it, but we cannot explain it. So that's a big key difference, understanding that hypotheses are guesses, laws describe, and that leaves us with, oh, here we go. So we don't really know. In other words, we don't know how gravity works. And that's why we can't fly. As soon as we figure out which of these theories is right, like, oh, here's why gravity happens. This is doing this with this and this, or there's some unseen particle. It's like, oh, well, if we could explain gravity, then we could break it. We'd have gravity boots. We'd be able to fly. We'd be able to weaponize it or some sort. It's like, yeah, we don't know what's going on. So, there's lots of other things here. Ohm's law is a product of electricity versus resistance. The more resistance, the less electricity let flow through. Law of thermodynamics, every single time energy goes from high to low. That's just a readily observable thing, therefore it's a fact. So now a theory, which is the most important thing in all of science. And we hear like, oh, I have a theory about that. That's my theory. What's your theory? Like, you're probably using it wrong. I'm going to read this to you because this is the best summary I've ever heard in my life. Scientific theories are hypotheses that have been so thoroughly tested and confirmed through experiments designed to disprove them, and so well established that new evidence is not likely to contradict them. The difference between a theory and a hypothesis is the very large degree of confidence we have in its validity and its power to explain. When someone says, oh, it's only a theory, they are most likely using the word colloquially and not scientifically. Theories are very powerful explanations and have withstood repeated attempts to disprove them. Nevertheless, theories are still proposed explanations, and all the criteria for a scientific hypothesis still apply. So they are the best explanation we have. Could it be wrong? Absolutely. It's been rigorously tested and designed, tested by experiments, made by scientists, tested by scientists. It's backed up by tons of evidence. It has yet to be disproven. Could it be potentially disproven? Absolutely. And that's why we leave disc number 10 closed. It started by a hypothesis made by one person, and it's now accepted by many. And if the people don't accept it, usually we ask them to make an experiment showing that it's wrong. We never ever reach 100%. You don't prove it because that's not what we do in science. So why do we even have these theories? Well, here's a whole lot of examples of this. Like, plate tectonics is the best explanation for the formation of the continents, mountains, rifts, valleys, everything. The Big Bang Theory, although we could never repeat it or see it, it is the best current explanation for astronomy. Music theory. Waves come together and overlap in ways that are pleasant, because waves that don't overlap and mesh, it's not pleasing. That's music theory. You can't see music. On the test, you really need to know these three things right here. This is question number 1 on your test. A lot of information, but Very simple conclusion.